Yes, certain strains can replace a significant portion of fish meal in some diets without hurting fish growth or health. Plus, there's this other interesting angle.
Hmm.
You can potentially enhance them during production, maybe tweak them genetically, or adjust the growing conditions to make them produce extra vitamins, or specific pigments like astaxanthin for salmon, or other compounds that boost fish health.
A whole new era of communication in the global aquaculture industry is coming. Now you have the brightest minds in aquaculture right in your pocket. And what's best? You can listen to all of them while driving to a farm, traveling, or running errands. It's never been this good, and it's never been this simple. Welcome to the Aquaculture Podcast Show, the first AI-based podcast in aquaculture, where you'll find cutting-edge insights in everything that's working in aquaculture, nutrition, health, and production.
Welcome to the Deep Dive. Today we're jumping into something really critical for U.S. aquaculture, the need for truly sustainable aquafeeds. The old ways, relying so heavily on fish meal and fish oil, they're just running into limitations, aren't they?
They really are. That reliance on wild-caught forage fish, it's not just causing ecological problems in the marine food web, impacting, everything up the chain.
Right.
But it's also getting economically tricky. The supply isn't always stable, and the costs, well, they're definitely a factor. The push for alternatives is getting stronger every year.
Exactly. And that's what we're focusing on in this deep dive, the potential of microorganisms. We're talking microalgae, yeasts, fungi, even some bacteria as potential game changers for aquafeed ingredients.
It's a super interesting area, huge potential, definitely, but also some real technical challenges to get them fully integrated. We should probably touch on the innovations happening too, the tech that's trying to make this work on a big scale.
Okay, good plan. Let's maybe start by unpacking why the traditional approach, the fish meal and fish oil model, is causing so much concern now. What are the biggest red flags?
Well, the fundamental problem, and I'm sure your research pointed this out, is the source itself. It's finite. Fish meal and fish oil mostly come from these small, oily fish, anchovies, sardines, menhaden, the forage fish.
The base of the food web, essentially.
Precisely. They're critical food for larger fish, marine mammals, seabirds. The whole system relies on them. So heavy fishing pressure on these stocks doesn't just affect them, it sends ripples upwards. It can really destabilize marine ecosystems. We risk undermining biodiversity.
And you mentioned the economics earlier. That's a big driver too, right?
Oh, absolutely. Fish meal and fish oil prices, they've been trending up. There's volatility in supply. Global demand is rising. It hits the producer's bottom line directly.
And the carbon footprint.
That too. The fishing fleets, the processing, the transport, it all adds up. It's a significant part of aquaculture's environmental impact profile, something the industry is increasingly aware of and trying to address.
Right. So, okay, given all that pressure, it makes sense why everyone's looking for alternatives. Microorganisms, especially microalgae, seem to get a lot of attention. What makes them stand out?
What's really compelling about microalgae is, well, their nutritional package. Certain species are powerhouses. They can produce high levels of good quality protein, but also, crucially, those long-chain omega-3s, EPA and DHA.
The ones we usually get from fish oil.
Exactly. So these tiny organisms can basically synthesize the very nutrients we're currently harvesting from wild fish populations. It's a direct route, potentially.
So it's a 2-for-1, almost protein and the essential fats. That feels like a significant advantage. How are they being used now, or what's the immediate potential?
Right now, it's kind of two main approaches. They can be used as a supplement, added in smaller amounts to boost the overall nutritional value of a feed.
Okay.
Or they can be a more substantial ingredient, actually replacing a decent chunk of the protein or lipids in the feed formulation. It really depends on the specific algae species and what you're trying to achieve nutritionally.
You mentioned innovations earlier. What's happening on the tech side to make microalgae more practical, more scalable?
Yeah, that's where a lot of the work is focused. Big one is optimizing how we grow them, the cultivation, fine-tuning everything. Light, CO2 nutrients, temperature, pH. Trying to maximize growth and get the nutrient profile just right consistently.
Making it reliable.
Exactly. And then there's scale, moving from lab flasks to large-scale systems like open raceway ponds or these enclosed photobioreactors, basically big controlled tanks designed for optimal algae growth.
And cost, presumably.
Cost is huge. Getting the production costs down is absolutely critical. So innovations in how you harvest the algae, get the water out efficiently, and process it into a stable feed ingredient, that's all essential to make it economically competitive.
Makes sense. The whole chain needs to work. Okay, what about yeasts and fungi? They pop up in discussions too.
Yeah, they do. Yeasts like Saccharomyces, Cerevisiae baker's yeast, basically, or Candida utilis, and certain fungi, they're definitely being looked at hard as protein sources.
That's their advantage.
One big plus is they can often grow on cheaper feedstocks, sometimes even agricultural side streams or byproducts. So that adds, another potential sustainability angle using waste streams.
And protein-wise, can they actually replace a good amount of fish meal?
Studies are showing that, yes, certain strains can replace a significant portion of fish meal in some diets without hurting fish growth or health. Plus, there's this other interesting angle. You can potentially enhance them during production, maybe tweak them genetically, or adjust the growing conditions to make them produce extra vitamins, or specific pigments like astaxanthin for salmon, or other compounds that boost fish health.
So like a value-added ingredient. Interesting. And then bacteria. You hear about things like methanotrophs.
Right, the methane eaters. Certain bacteria are being explored because they have exceptionally high protein content, and the idea of feeding them methane, which is a potent greenhouse gas.
Kind of closes a loop, potentially. Yep.
Potentially, yes. Using waste methane to produce feed protein, that's an attractive concept. Of course, there's still research needed digestibility for fish, safety, scalability, but the protein levels are promising for replacing traditional ingredients.
So we've got this range of microbial options. But how do we ensure these alternatives are actually sustainable? What are the key strategies?
Well, fundamental is rigorous evaluation. You have to know exactly what's in them. Nutritionally, amino acids, fatty acids, minerals, vitamins. Does it meet the target fish species needs?
Sure.
And at the same time, you need a full environmental assessment. What's the impact across the whole life cycle, from growing them to processing them?
And that's where things like digestibility and FCR come in, isn't it?
Absolutely critical. Digestibility. If the fish can't break down and absorb the nutrients efficiently, it doesn't matter how good the profile looks on paper. We need solid data on how well fish utilize these new ingredients.
Because that impacts the feed conversion ratio.
Directly. The FCR, how much feed it takes to get a kilo of fish growth. If you have highly digestible ingredients, you generally improve the FCR.
Which means less feed needed overall.
Yeah.
Better sustainability.
Exactly. Less feed means less demand for raw materials, lower energy use in making the feed, reduced greenhouse gas emissions, all down the line. Plus, better digestion often means less nutrient waste coming from the fish, which helps water quality.
It's all connected. You mentioned life cycle assessments, LCAs, earlier. How do they fit into evaluating sustainability?
LCAs give you that comprehensive picture. They look at the environmental impacts across the entire life of the ingredient, from getting the raw materials through manufacturing, transport, use, everything.
So you can measure energy use, emissions.
Things like resource use, global warming potential, eutrophication potential, that's the nutrient runoff issue, effects on biodiversity. It lets you quantify the impacts and compare these new ingredients directly against, say, fish meal or soy on a level playing field. Helps identify the genuinely better option.
Okay, that makes sense. Rigorous evaluation is key.
Yeah.
But what are the biggest roadblocks right now to actually getting these microorganism feeds widely adopted?
Probably the biggest one still is production cost, especially for things like microalgae. They need to become cost competitive with the established bulk ingredients like soybean meal or corn. Those have huge economies of scale already.
Right, decades of optimization.
Exactly. So scaling up microbial production while driving down costs through tech improvements and efficiency gains, that's the major focus for R&D right now.
And what about just quality, consistency?
That's another big one, yes. Aquaculture producers need feed that performs predictably every time. If the nutrient content of a novel ingredient varies too much batch to batch, or if there are unexpected compounds,
it messes up growth predictions, feed efficiency.
Precisely. It impacts the fish and the farm's economics. So robust quality control, standardized production methods, absolutely essential to build industry confidence.
And regulations. You touched on GM earlier. Is that a hurdle?
It can be. Genetic modification offers potential, like boosting specific nutrients in crops or even the microbes themselves. But the regulatory path for GM ingredients in feed can be complex. It varies globally.
And public perception plays a role, too.
It does. Public acceptance of GM in the food chain is still a factor. So navigating the regulations and ensuring transparency and rigorous safety assessment, that's all part of the puzzle.
It really sounds like getting this right needs everyone pulling together.
Absolutely. It requires close collaboration. You need the researchers, nutritionists, microbiologists, engineers, ecologists. You need the industry, feed companies, fish farmers, and you need policymakers creating supportive, clear regulations that balance innovation with safety and sustainability.
Looking ahead then, the promise seems pretty clear. Using microorganisms can really shift things for aquaculture.
I think so. The potential to drastically cut the reliance on wild fish for feed is enormous. If we can successfully integrate these sustainable alternatives, we can significantly lower aquaculture's environmental footprint. Less pressure on marine ecosystems, lower carbon emissions. It's a big deal.
So it's not just about being greener, it's fundamental to the industry's future growth and long-term viability.
Exactly right. As global aquaculture continues to expand, and it needs to meet protein demand developing and, crucially, scaling up these sustainable feed solutions is going to be absolutely essential. The research needs to continue, the technology needs to advance, and those partnerships need to stay strong.
Some really key points there. It's definitely a dynamic space to watch. Thanks for diving deep into this with us today. And for our listeners, hopefully this gave you a solid grasp of both the challenges and the exciting potential in sustainable aquafeeds. Definitely something to keep an eye on as it develops.
If you enjoyed this episode, make sure to follow the Aquaculture Podcast Show on your favorite platform. And don't forget to follow us on LinkedIn, Instagram, and Facebook to stay updated on the latest episodes and industry insights. Thanks for tuning in, and we'll catch you next time.